Right, can you all hear me? Are we there? I'd like to introduce Professor John Onians, who's Professor of History of Art at the University of East Anglia, and for the last 20 years, is that right, John? Is it that long? Has been pursuing his very unique and very special investigations into the role of neuro art history, which has raised some very important and interesting ideas about the brain and the history of art. I don't need to introduce him very much because he's brilliant enough on his own, and he's also colourblind, so he'll talk to you about that. Thank you.
Thanks very much. And I should say, I must say, we've all I've been bathing in neuroscience, and I do think it is wonderfully addictive stuff. And I also I feel challenged by the precision and the rigour with which it's discussed here. There's a real aesthetic pleasure to hear neuroscientists talk about their materials. But I should also say that I'm going to illustrate the difference between scientists and people in the humanities by the very loose, irresponsible, impressionistic way in which I'm going to use neuroscientific knowledge today, because I think it's one of the values of having contact between the humanities and the sciences is that each should infect the other with what's special about them. And I do think that I certainly needed to be infected by scientific rigour, and I think that the scientists, I don't think they need it, but I think, as it were, their work can only become more interesting if they push the envelope of the imagination, imagining what their findings might imply about the human mind and what it's like to be a human being. Anyway, as you will very rapidly realize, I was forced to acknowledge the importance of neuroscience when 50 years ago now, I got a job as an art historian at a Dutch university, and I went to this is not the real person basically, but in order to become to work at a Dutch university, then you need to become a Dutch civil servant. In order to become a Dutch civil servant, you had to have a medical test. I had no idea what they want to check. When I just previously had a medical tech to go to America, have a job there, and all they wanted to know was whether I had VD. I didn't know what was going to be in the. When I had to go and see the doctor, and he had his file on me, and what he said to me really set me back. And what he said was, "Dr. Onians, I see that you are colourblind. I don't think you can have this job as an art historian." And at this point, I said, but I work mostly with buildings. He said, "So what? There's a blue building in my town." And I could see that this was, he obviously, since the art historians thought I could have the job, it's very, I didn't expect him to be really tell me that I couldn't have the job, but it did make me think, my God, there is an issue here. And I suppose ever since then, I've been trying to see the reasons why it might be a good thing to have a colourblind art historian. And there's no doubt about it. For me, the most important thing is that I need to know about neuroscience, because I need to know what are the defect, what is the defect, the neural defect that I have, and what are the benefits it might have. Probably most of you will know that the reason why people have colour blindness. I mean, the most frequent type, I have one type of red-green colour blind. There are several types. Everything's more complicated than you think it is. And, but this slide illustrates the fact that we have these three cones in the back of the brain, in the back of the eye, and that these three cones read different, respond to different wavelengths of light, and this enables us to have polychrome vision. This is, and the reason why that's so important is you again, something I discovered quite rapidly was that there are monkeys up until 40 million years ago didn't need colour vision because they all ate leaves. Now they spend all their day eating leaves because leaves are not very nutritious. And then there was a mutation, and in one monkey population, this mutation produced an extra cone, and the way evolution works, a job was found for this cone, and it was to give them polychrome vision. So they could now become fruit eaters and pick nutritious fruit, which is ripe, because they can see red-green difference. And by knowing to eat the ripe fruit, the red fruit, they're going to have much better nutrition, and this enables them to have bigger brains. And of course they need a bigger brain because they have to remember where in the forest the ripe fruit is. And they have to always remember what time of year. So in other words, there are lots of benefits to our monkey ancestors who had polychrome vision. So that's a very clear asset, and humbling, because it made me realize that I was really a lower level of life. I was designed to be a leaf eater. And I should say, obviously, that the discovering that we're now supposed to have a vegetarian diet, we're supposed to ideally, to preserve the planet, we should all be eating leaves. That I'm anticipating, the next development in the human race. Anyway, but the downside, the deficit, obviously, beside the fact that I have an affinity with an inferior type of monkey, it means that I don't respond properly to the pink and red things in the environment, which I need to respond to if I'm going to transmit my genetic materials. So that, for instance, nipples and lips and things like this, sort of, they don't. I mean, I've learned to appreciate them, but they don't. They didn't. If they weren't labelled, I wouldn't know what to do with them. That's, and I think there is an analytical skill which is developed by colourblind people, which is.
Most people can control themselves looking at the picture.
Anyway, it is a question that I'm really. I do not know when I see. I mean, my my wife, or I look at other women, and I know what I'm supposed to want. I'm supposed to want to kiss them and grab them and do things because the colours would. I'm biologically programmed. My neural equipment is programmed to lead me to do that, but I don't, of course. So I have a more Olympian view of the. And as far as I know, nobody's really studied what goes on in the brain of the colourblind person confronted with an attractive female. But it does mean that, sort of what pink underwear looks grey, red lips tend to look, red lipstick looks black. And that's a problem. And of course, as an art historian, I'm supposed to be able to describe this Renoir painting, and I can't. And the same is true of these Cézanne peaches and apples and things like that. I don't. So in other words, the two things that I need that I am genetically designed to choose the best of, women and fruit. I can't do this. And this, of course, is why I had to marry my wife.
I just have to comment on the genetic reductionism and maybe just gently query that was all.
Okay. Well, this is exactly the type of this debate we need in order to complicate all issues. But anyway, it is. There's clearly a problem for me as an art historian. Now, one way of getting around this problem is when I can't see the colours, it helps me. This is before I met my wife. I was in the Louvre. I was going to write an essay. I was a graduate student in London. I wanted to write a paper about Correggio's paintings, and I knew that he used a lot of pink, and so I couldn't see the pink, but there was a busload of English school kids who were going through the Louvre at the same time as me, and I asked them if they could help me, and I had about 10 of these kids, and I was going through paintings like this Correggio, and they were pointing out to me exactly, where the pink was and what type of pink it was, and I like to think that the paper I wrote as a result was one of my best. And it's probably the only paper I've ever written purely about colour. Anyway, these are ways of living with the deficit. But what are the assets? Now, the most obvious asset is illustrated by this example of colour camouflage in the natural world. Obviously, the natural world is full of cases where animals or plants have a colour which is designed to make them invisible to predators. This is a good example in the case of a moth. Now, the recognition of the importance of camouflage in the natural world led people, military leaders in the late 19th century, late 20th century, to apply this idea of camouflage to soldiers and to develop different types of camouflage materials like this. There were many types of them. Now, that's very good because but it only deceives people with normal colour vision. In other words, when camouflage was developed in the army, they then started to advertise for colourblind people because they will have a better chance of seeing through the camouflage, which is designed to operate on people with normal colour vision. So I thought that was really that's very reassuring to me, and it does raise an interesting question. And again, I don't know whether anybody's worked this. As you probably know, there's something like, whatever it is, 1 in every 5 men is colourblind. And the question is why this is so. And one explanation this is one I thought up myself because I like to think of a reason why I might be necessary in the big picture of the history of humanity. But if you think of our ancestors often going out hunting, and a hunting band is likely always to have been made up of 2, 3, 4, 5, 6, 7, 8 males, and often going after large lumps of protein, which are dangerous, which is why there are so many. And it helps if there is one person in the group who is colourblind. In other words, the selection, if probably more colourblind people, then that wouldn't work because then you'd be eating more unripe apples. But if there's one, that's a help. So I don't know whether it's possible. I have run this problem past geneticists, and nobody's ever given me an answer. Maybe is there anybody here who might could produce an explanation for why there is this proportion of colorblind people. Anyway, that's the thing. And another thing that I noticed when I was young was that I had very good vision, very clear vision. You know, I could read the bus number, you know, when it was farther away than most people. And I was talking about this to a neuroscientist, and he said, well, it's possible, and again, he didn't know whether it was true, but he said it is perfectly possible that the optic nerve is capable of sending a given amount of data, and that if it's not transmitting color data, it may be transmitting more data about in tone, and you know, so that making edges more visible, whatever. So it's possible that these are possible assets, which coming with this particular neurological defect. Now, I subsequently, I should say, when I first started thinking about these issues, which I did as soon as this Dutch doctor had told me I shouldn't have a job, and I started to take it much more neuroscience much more seriously from around 1990, because a lot more information about our neural equipment became available due to things like MRI and so on. Anyway, so I immediately, from about 1990 onwards, I got interested in neuroscience. And one of the things that I learned very rapidly is that the way that the different areas of the brain are occupied principally with different activities, as is illustrated here. And then many more complex, different, much more nuanced differences, which we've heard about from Joel and from Crawford. But then I started to think, why do we have a brain in the first place? Does anybody know why we have a brain? Why do animals have brains and plants don't? Sorry? Yeah, it's to move. It's to move. Basically, a plant is able to reproduce and feed itself without moving. We only need a brain to help us to move in ways that again enable us to transmit our genetic material by feeding ourselves, defending ourselves, and reproducing. And the importance of this transition, the difference between a plant and an animal, is brought out by this creature that we're looking at, which is a sea squirt. I don't know how you know about sea squirts, but we should all know about sea squirts. Anyway, but the sea squirt begins its life as an animal, swims around the ocean until it finds a place where it can attach itself and assure itself of getting its nutrition and reproducing. And at this point, the sea squirt proceeds to ingest its own brain. And because it doesn't need it anymore, which is why it's been unflatteringly compared to a professor getting tenure. and I should say, you're laughing, but I was when I was talking about this at Brown University a few years ago, and I didn't know. I noticed that somebody left the room, but I didn't. You know, people are often leaving the room during my lectures. I wasn't surprised. Anyway, but afterwards, somebody said to me, you know, that was somebody who just got tenure. So you have to be very careful what you're saying. Anyway, the important thing is, because we need a brain to move in order to transmit our genetic material. All animals have a brain which is opposite to their particular ecology and needs. And one of the earliest and very elegant demonstrations about how individual neurons work were done about the frog brain, and the frog brain has neurons which are triggered by dots, but not just by a dot moving across the screen. If you can see on the left-hand side, the frog is seeing a dot move, but that's not going to activate it. What he has, the dot has to be set against an environment in which things are not moving. In other words, the frog is only interested in the fly and not the leaves, the seeds, and everything else around it. Why the frog only really reacts most when he's looking at a pretty picture of a landscape, as it were, and the fly is buzzing through it. Anyway, I started to discover more and more about what made us special, and I discovered that we have all sorts of things which are wonderful. That because we're designed to survive, or our genetics means that our brains enable us to survive anywhere on the planet. They do that because we'll acquire a brain which is appropriate to living in the Arctic or in the tropics or in desert or on a mountain and things like that. And that's because our brains do this because our brains are very plastic. They're shaped by our particular experience. So obviously all creatures have to some extent plasticity in the neural cortex, but in our case it's very highly developed. Anyway, so that this plasticity, the fact that our brain is shaped by our environment, is very important. And it's also important that we have very good shape perception, because we need to almost anything. We can eat and use almost anything. And so we have to be able to organize, choose the right shapes and adapt tools to particular shapes. And also we have to empathize with what a particular material can do. And this is why we're able to survive. And one of the things that excited me most was to realize how much animals can, because they have animals which are like us, comparable in this types of have a comparable history of development, like dolphins, that they have neural resources which enable them to do things which are as complicated as some of the things we do. And this is illustrated by this, what you see here. There's a man in an aquarium, and he's smoking. Of course, you can't do that nowadays, but in the old days, you could smoke in an aquarium. Anyway, the man is smoking, and he was puffing a cigarette, and he noticed at one stage that a young female dolphin saw him do that, and she then swam off to her mother and took a suck of milk and came back and blew an identical cloud of milk. And the point is, there was no instruction, there was no inducement. This is purely neurally driven. The dolphin has, as we have, very good shape perception. So she recognized the cloud of milk as a special thing. She can remember the way she'd created a similar effect when she'd seen milk leaking from when she was suckling from her mother, and she knows that, or her genetic material rewards her if she will repeat the action of a dominant, superior, older or better. And so she goes on and takes a suck and comes back and shows that she understands the importance of this. And she gets a neurological reward, probably a squirt of dopamine, and that's really important. And we spend thousands of pounds sending our children to university art school to do this sort of thing, but they don't need that. They can just do it for free, because it's amazing what the human neural equipment will do. Anyway, I applied this knowledge to understanding the history of art. Now, this is, some of you may know this, is a figure on the wall of the cave of Chauvet in southern France. And what is fascinating about this image, it's prehistoric, it's very old, it's Stone Age, but it's also literally one of the oldest, if not the oldest image ever made. This is, and so it's not what we were taught at school and at university. We were taught that human beings started by doing stick men, and then they ended up doing the things like Raphael and Leonardo and Michelangelo did, with perspective and so on. But here, this is a bear drawn in 3/4 perspective. And you're not going to see another figure in 3/4 perspective for another 30,000 years. Clearly, these individuals in this cave were somehow using perspective without any instruction. They certainly had no discussions about these things. They're just doing it, and there's not an elaborate culture, not a lot of people coming together and talking about things. Very few people ever went to this cave, and it's clear that what was going on was that, and you can tell in this case, as in many other cases in caves, an image is suggested by a marking in the rock, and you can see where the left forepaw of the bear is already there in markings in the rock. Certainly, the person who made this image must have looked at the wall and that the line of where the forepaw is suggested the image of a bear seen from above in 3/4 view. And that is a very intense visual memory of what a bear looks like seen from that particular point of view. And of course, the reason why the human being who made this, had a very intense memory of the bear is because he's very jealous of all the assets that the bear has in terms of a fur coat, big teeth, big claws, and great capacity to smell. In other words, and humans looked at the bears and said, and they didn't realize it, but by looking at the bears with this particular intensity, remember these are humans who've only recently come out of Africa with no protection against cold or anything. They've only come north because there's this lot of these large lumps of protein which they want to go after, and they are giving a particularly intense attention to their environment, and that intense attention is giving them neural resources for the perception of...
It could have been a woman.
Sorry?
It could have been a woman.
It certainly could. I mean, we can have a very interesting discussion about it. But the point is, since I think the greatest likelihood is that these are people who are hunting bears, that it's going to be male. But I agree, there's nothing. It's not.
Bears are scary, and it might be because you're very aware of the need to protect yourself and the other people around you and your baby, that you're very aware of what a bear is.
No, I mean, I would like to think so, but I would discourage my wife from going out and looking at bears when she's supposed to be looking after my baby.
Well, I'm not anybody's wife, so...
Well, but you're quite right. No, we should absolutely not assume that, and you shouldn't be believing anything that I'm going to tell you. But it all comes, because it comes from me, it has a health warning. Anyway, so that's what a cloud in an aquarium meant for a dolphin. Now, this is, you'll recognise this is a photograph of one of the Twin Towers burning 9/11, and quite a lot of people saw in the clouds, they saw a face Some saw Osama bin Laden, others saw the devil. This is, subsequently somebody. Obviously, it's shifting. The clouds, the shapes are shifting constantly. So it's not a picture, but it evokes, make people see it. And the point is that the reason why people saw Osama bin Laden, or they saw the devil, is because they are thinking, who did this? And obviously, the individual, if you can, it's that this monstrous, Osama bin Laden. And for those people who believe in, gods and devils, the devil is the person it's his handiwork. Anyway, the reason why we have a tendency to see things in indeterminate shapes like clouds is because of our, fight or flight mechanisms. That when if we're in a dangerous situation, our sensory apparatus is primed to look for danger, and if we need food, we'll be primed to look for food. So we'll, as Gombrich said, who was my teacher, said years back, he said it's a hungry hunter who is going to mistake a tussock of grass for a rabbit. In other words, you only do it when in stress, because neurochemicals play an important role in affecting what we see. Well, I mean, sure. We're into the world of imagining things, and this is where we come back to what Crawford was talking about this morning, the superior parietal lobule. And this is an image of the superior parietal lobule, and which is very important for our imagination. And of course, you can be imagining you only have to read about the devil to imagine the devil. You don't need to be looking at a cloud of smoke or something like that. In other words, a lot of our imaginative life, a lot of our imagery, our visual imagery, is fed by texts. And you'll recognize an image from Crawford's wonderful presentation, which is giving a new precision to the location of these resources of the human brain. And here we see an image sketching in a coarse form the default mode network. And this has, as you see, it's got the sophisticated conscious elements on the left, and the more passive unconscious elements on the right, the visual cortex at the back, but a whole series of resources which are involved in the default mode network. And I think Crawford may have suggested that people were almost too interested in the default mode network. And I'm certainly one of those people, because it comes close to defining personality, because the default mode network links memory areas, so all things of your past, including specifically your autobiographic memory, your sense of your state and well-being at the time, and it links that with your capacity to envisage the future. Because basically what the default mode network does, it sets you up to, it adjusts you to whatever your environment is. What you need is, what you're going to need now is this or that. This is what the default mode network is active, where we're not performing a specific task, and in fact it's preparing us for the next task, whatever that's going to be. And it's if you go through, if you find out about the default mode network and you learn about all the different things that it does, I think you'll have a feeling, as I did, wow, that's really what I am. Because in all these cases, it's what's important is it's the information that's relative to your particular being and your particular life and your particular environment and your particular needs. Anyway, as an art historian, and here you see the way the many different areas which are linked in this default mode network, and I use the concept of the default mode network to try and understand individual artists, like Leonardo da Vinci. So I can go through an account of the different areas of the brain and say, what would Leonardo da Vinci have had in those areas? What neural resources, what's specific to him would have been in them? Which would have enabled him to make this extraordinary painting. And one of the reasons why I'm very glad I was forced to think about this painting in neurological terms is because I like to think that I came up with a reason for why this painting has such extraordinary power. I mean, it is the most famous painting in the world. And if you read all that's written about it, people say, well, it's very evocative, it's very beautiful, it's very well painted. But there isn't a particular reason why it should be so powerful. And I connect it to Leonardo's specific neurological history. Anyway, Leonardo writes a lot about the way he feels the brain works. And he talks very beautifully about, he says, if you want an inspiration for a painting, look at a dirty wall. Look at a stained wall. Because if you look at the stained wall, you'll see whatever you want to see. Soldiers fighting, horses running, animals. You'll see whatever you see, whatever you want to see. He was aware that basically if you look for something in something like a stained wall, you will find it. And he says that's the way you can get an idea for a composition. And so he's really recommending the sort of process that whoever made that painting in the Grotte de Chauvet 30,000 years earlier was using, but he's recommending it as actually an artistic practice. Anyway, and you see he has sheets on which there's a swirl of lines, and out of this swirl of lines you get emerging horsemen and fighting figures. But Leonardo is most famous for his bigger drawings when he looked at particular objects. Particularly, he looked at leaves, he looked at waterfalls, he looked at the human body, and he looked at the brain. And this is one of the most important drawings that he made because it's a drawing. It's the first drawing that shows an understanding of the neural resources which give our face its expressive capacities. He shows all the different nerves that go through our cheeks, our lips, and so on. Now, he's literally the first person who's seen that, and he's meditated on it. And if you look at earlier, he's drawn the brain and the skull earlier on, and he doesn't show it. This is made in 1506, as just when he's working on the Mona Lisa. So when he was working on the Mona Lisa, he was discovering that the human face is filled with these nerves, and he shows how these fibers go straight to the brain. In other words, it's not... So he shows that there's a connection between the most superficial outer surface of the body and the deepest inner workings of the mind. Now, he's the first person who sees this, and obviously he's not making many paintings after this. He's dead in 10 years. So this painting, the Mona Lisa, I would argue, has this particular power, because when he looked at the face, he actually saw the nerves in there. I mean, he's imagining them. They are in his imaginative memory. And because he'd looked very hard at things, he had much more powerful imaginative memory than most people. Anyway, and I think it's also important that as he was making the painting, he had also, when he discovered this about the nerves in the human face, he can feel the nerves in his own face. And as he's painting the Mona Lisa, he's going to, I'm sure he's going to start to smile. And she smiles back. And because that's what happens, you know, our neural equipment leads us to mirror those people who are looking at us. And this is true whether we're a baby looking at a mother or two lovers meeting in a cafe or whatever it is. And so he is having this loving relationship with Mona Lisa only because he understands the role of nerves in linking the skin to the brain. And this is why I think people don't realize it, that everybody who looks at that, most of us never get close enough to the painting to be moved by it physically the way he was. But I think anybody who sees this painting is going to unconsciously, their neural equipment is going to predispose them to want to feel like smiling back, and to establishing a warm relationship with it. And it's this warm relationship which, in my view, leads to this painting being the most famous painting in the world. And of course, the reason why there's never another painting which has this property is because no other artist ever knew about these nerves. I mean, neurologists came centuries later to understand this, but from the 18th century, neurologists knew about these nerves, but they weren't painters, and painters didn't see it. But Leonardo was exceptional. He was a painter who was acquiring a neurologist's expertise. Now, I want to. This is slightly naughty because I'm going to now talk about another example of a neural deficit, which is very different from mine. I mean, I have this neural deficit of colourblindness. The neural deficit that I'm talking about in the case of Francis Bacon is something which I'm imputing to him, and which I may or may not be right. But basically, I know the person who did the catalogue raisonné of Bacon's art, and he heard me talking about what I was doing, and he said, I'm doing a book on Bacon's mind, and I would like you to write about Bacon's brain. And I had no knowledge about Bacon. My expertise as an art historian is in classical antiquity and the Italian Renaissance particularly. So I didn't know anything about Bacon, but I do work in the Sainsbury Centre where there are, in fact, 14 Bacons. So he's somehow familiar to me. I felt at ease with him, but I had no idea what I was going to say about Bacon's brain, what was different about his brain from anybody else. Anyway, I started to find out about it, and I'm going to summarize my conclusions. But anyway, this is a Bacon painting, a self-portrait from, I think, 1978. And it has one of the features of this painting, as of many of Bacon's paintings, is that there is a sort of rail running round it. And you see a human figure with a railing nearby, something that looks, we don't know whether it's a railing, but it looks like a rail. Lots and lots of paintings have railings around them. And in fact, Bacon got into art, first of all, by making furniture, and it was furniture which was made out of stainless steel rails. That was long before he got into painting. And I should say that because Bacon never went to art school, he in fact only went he only went to any sort of school for one term. His brain is not shaped, as most artists are shaped, by artistic training, and his brain is not shaped by the normal processes of education. The main factor affecting the shape of his brain are his experiences, the things that he's giving intense attention to. And I think the most important thing that he was giving attention to was racing, horses. He basically, he was very interested in racing, horse racing, dog racing, and the reason I think he was so interested in dog racing and horse racing is because his father was a racehorse trainer in Ireland, and his father was also master of foxhounds, so he was, breeding dogs. And basically his father, if you're in the business that, raising racehorses and raising dogs, the most important thing to do is to shoot all the duds. And because that's the way you get the right quality stock. Now, unfortunately, poor Francis Bacon, who should have become, a great athlete, a great soldier, a great sportsman, a great rider, he had terrible asthma. And so his father regarded him as a dud. And he was dying to be loved, dying to be respected by his father. And he wasn't. His father just had no interest in him, contempt for him. And in my view, that means that Francis Bacon empathized with these horses and these dogs, and he sees himself as being like a horse or like a dog, and that he's photographed for Vogue with these sides of beef, and his cousin of his describes how when they were young they were driving through the Irish countryside and he saw a butcher's shop and he said, we've got to stop, I want to go inside. And she said, why are you going inside? He said, because I think I may find myself in there. Because, in other words, he identified with the sides of beef because he thought he might end up in that way. So that there is this quite unique relationship that he has with animal flesh, and which I think had a profound effect on him. And this is his last painting, incidentally, which is a painting of a bull with something of an evocation of a bullfight ring. But you get the sort of the rail thing in the background. Anyway, the man who wrote the Catalogue Raisonné of Bacon describes this painting and says, I think this painting is like a personal autobiography of Bacon. He doesn't explain why or what but he said that. Anyway, when I sent him my piece about Bacon, I thought he might think this is a load of rubbish. I don't believe it, I don't like it, I don't want it. Because he could have just completely turned down, but he said he loved it. He thinks, I think it's absolutely right. Nobody's ever said anything like it before. Anyway, and so the book will come out in a month's time. It'll be launched at the Royal Academy in London. And it's not proving anything about Bacon or me, but it is nice. I like the fact that because Bacon, I think, became so famous because his paintings have a quality, one of which is their inflection by his experiences of horses and dogs and butcher shops, which gives him a particular empathy with those animals. And so it has its roots in his neural deficit, and of course he died of asthma. He died of an attack of asthma. So in other words, that it really was brought his end. But anyway, it had, before that, it inspired, I would argue, a major dimension to his creativity. Anyway, and of course, and the fact that I would like to think that the fact that the editor of the Catalogue Raisonné of Bacon wants and likes my contribution to his book on Bacon's mind is a proof that the doctor in the in the Dutch government, office, who told me, I was unsuitable for art history, and as it were, should be shot. That he was wrong. But anyway, that's up to you to decide. But these are my free meditations on neural deficits and the assets that I have tried to make for myself. Thank you.
Questions? Possibly.
Correction. Yeah.
Have you tried out the chroma glasses yet?
No, I did the test and sent off my replies, and they wrote back and they said, we can't help you. You're off the spectrum. So I never found out. They did tell me what the name of my particular form of colourblindness was, but I can't recall it. But it made me realise that these things is much more complex. So.
I used to run a clinic for work-related eye problems, and so I got asked whether people could become firefighters with deficient colour vision. I call it colour deficiency, not blindness. I don't think.
No, you're quite right. You're quite right.
And I'm delighted to hear you tell us about the advantages. It's so difficult often to have somebody who comes in with an apparent disability and try to give them the positive side of it. I really enjoyed that. Thank you.
A bit of a technical question on point. I've been tweeting about things I've found interesting, including what you said about Francis Bacon, but then with you saying it's in the book out next month, would you prefer that I delete that? Or is it okay?
Sorry?
I've been tweeting about what I found interesting during the lecture, but then you've just mentioned about that your work on Francis Bacon hasn't come out yet. Would it be best for me not to?
I mean, I don't know what is the. I don't know about tweets. Adam, do you think the fact that this lady's wondering whether she should
go ahead, I think.
Yeah, that's what I mean. As far as I'm concerned, anything which increases sales. And I should say, it's not down in the gallery, but there's nothing quite like my book, European Art and Euro Art History.